Hello everyone and welcome to the Imp's Prison. I am the host Angelo, and every week I open this show up with what's known as a cold open. That's what this is, where I just sit here and I try to say all these nice things about the guest that's coming on, or, nice things about a past guest, or a related story about how we know each other, and so on and so forth, and blah, 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 blah. And why do I do this? Because at the beginning of the show, the actual recording with the guest, I reintroduce them anyway. So I wonder about this sometimes. Is this just become convention that now I must do it because it is what it is? Or is it something a little deeper? Is it just me needing my me time? Well, this week's guest is Cluze, and it turned out exactly how I expected it to. Hope you guys enjoy it.
Okay, so I don't know how much of an introduction this guy needs. I mean, last year he was on here and it was the episode that got downloaded the most. He was the guest that everybody said, oh my God, if you're doing a second season, you have to have him back. So I was like, all right, not what I expected, but sure. So I have a level 2 judge with me, but he's not on here for that. He's on here because he is employed at the University of North Carolina. They lost to Pitt the other night in basketball. Not that he cares.
Nope.
As a scientist, and his main field of study, and he can correct me if I'm wrong, is astrophysics.
That is correct.
And this is Cluze.
Well, hello. It's good to be back. Although that is a lot of high praise for my last appearance on this show. I hope I can live up to it.
Yeah, people love that episode, and realistically, as soon as I said, okay, I am doing a second episode, or I'm doing a second season, like, people flipped out. They're like, you gotta have Cluze back, gotta have Cluze back, gotta have Cluze back. And I'm like, okay, sure. I don't know, it's kind of good, to stretch people's minds a little bit. And what that means is we're going to do an episode kind of like last year's. Last year's, for those who didn't listen, please go back and listen. It was excellent. You're going to get a science lesson today, whether you want one or not.
Oh, that's good advice, actually.
Well, yeah, I mean, you need to learn, right?
That's right.
Speaking of learning, the other day, something happened to me, Cluze.
Yeah.
We recorded Monday night on Monday Night Magic together.
Right.
So the next few hours.
Which, by the way, I think that was one of our better episodes recently. If folks haven't listened to it, they should.
Oh, cool. Absolutely. Yeah, they should, just like the game shop.
That's right. They should check it out.
So a few hours later, my wife has to get up to go to work, and, she's had surgery recently, and she's not walking the best. So I have to go out, and I have to drive her to work. Well, if you live in the Northeast, you know that it is literally white up here. It's just snow everywhere. So I have to go out and I have to shovel my walk. So I'm out, doing my deal outside, with the shovel and throwing the snow. And then all of a sudden it gets really bright. And I'm like, wait a second. It's not even 5 o'clock in the morning. And I look up and I see something and I go, okay, I'm not crazy. But
well, now wait, hold it. I'm going to stop you right there. You might be crazy, but go on.
Okay, fair. I'm like, okay, I don't think I'm crazy. But I swear I just saw something. So, I'm like, all right, whatever. Day goes past, and then all of a sudden on the news, I live in a town, Cluze, called Beaver Falls, just north of Pittsburgh. I'm watching the news, and all of a sudden on the news, there it is, 60 miles directly above Beaver Falls, a 400-pound meteor enters our atmosphere and then explodes about 60 miles west of us.
Nice.
So I got to see a meteorite enter our atmosphere.
That is awesome. And a pretty hefty one at that. Hey, when I was on here last time, did we talk about Tunguska?
Tunguska. I don't know.
Okay.
No, the Russian one.
The Russian one. Okay. So, let's back up to meteors. Yeah. I mean, the Earth's getting, just kind of, not really pulverized, but barraged with rocks from space constantly.
Yep.
I forget what the actual number is, but a staggering weight of material falls to the Earth from space every single day.
Yeah, it's something like, there's something hitting us every second.
Yeah, and I mean, the weight, I think it's in the tons range per day that just falls to Earth from space. Now, most of the things that land are just tiny little flecks, they're just the tiniest little small things, but every now and then you get big ones. And Tunguska, in the early 1900s, there was this explosion that happened in the middle of nowhere in Russia. And I really mean the middle of nowhere. Russia's a very, very big place. And so there was this giant flash of light and a sonic boom that was supposedly heard as far away as London. I can't prove that. But they went out and they looked. And what they found was there was this big spot in the middle of the woods where all the trees had been laid down. And they'd been laid down kind of pointing away from the central spot. And in the central spot, the trees were still standing straight up, but all their branches were gone. And for a long time, nobody could figure out what the hell had happened. But what essentially happened is the same thing that just happened to you. A meteor entered the atmosphere and it heated up, it exploded, but it exploded above the ground, and it was a big enough meteor and exploded down low enough that it created a shock wave that just radiated out kind of spherically from where it blew up, and it just laid down all the trees, stripped the branches off the ones that were directly underneath it, and it was just this amazing, huge thing. You know, if something that big, which by the way, something that big happens on average like every 1,000 years or so, if something that big had happened over, say, New York, there would be no New York.
No.
It's big enough to just wipe out a city. So, you know, we have small ones constantly, bigger ones with slightly less frequency. If you had to ask me, if I were a betting man and you said, hey, Cluze, how are we going to die? Not any individual specific person, but how are human beings going to die? How do we get rid of life on Earth? When's it going to happen? Well, I can't tell you when, but the how is we're probably going to get hit by a rock.
I thought you said in 14 billion years.
Well, okay, look, I can guarantee that in 4 billion years, the Earth will be uninhabitable.
Okay.
But I think long before that, statistically speaking, we're going to get hit by a rock from space and all die. So, you know, you can take that as comfort, let's say.
Yeah, but as our technology advances, and I do want to get back to what I was to my rock in a second here, but
sure.
As technology advances, the possibility of us being hit by a rock decreases dramatically. Because we're beginning...
Yes and no. Our chances of being hit by a rock that we didn't know was coming decreases dramatically.
Right. But even the ones that we know are coming, I mean, there's contingency plans being formed constantly. It's like, okay, if this rock comes this way, how are we going to nudge it away? Because you don't hit these things with nukes. You know, that's bad.
Pretty much a terrible idea.
Yeah, don't watch Armageddon. That's a bad idea.
Oh, God. Actually, the science in Armageddon is some of the worst science in a Hollywood film absolutely ever. I hate that movie. Anyway, go on.
Wow, and I saw Gravity. Anyway, so, you know, like, to gently nudge it away or, you know, come up with something to pull it away from the Earth, because, you know, there's the idea of the gentle nudge. There's the idea of putting something beside it if it's far enough out where you can gravitationally begin to nudge it out of our range, you know, with a gravitational pull and all kinds of other things. But digressing back to my original question.
Sure.
So this rock hits. And
yes.
You brought up Tunguska, which is a great question because I actually was wondering, like, they said that this thing exploded over a town called Katanning.
Sure.
Which is, like I said, it's like 60 miles, to the east of me.
Right.
And this is a big rock. So
yes.
With the explosion, or they lost track of it, I didn't see no explosion. It never felt any shock wave, anything like that. And it's believed to have actually exploded above ground. So I was wondering why there wasn't like a Tunguska thing, because the reason Tunguska happened was because it exploded in the atmosphere above. Right. It's in some situations that can be worse than the ones that hit the ground. Why?
So it's kind of a matter of degrees. You said this was what, about 400 pounds?
Yes.
Yeah, okay, 400 pounds. It's not all that big. I mean, it's like, what, 3 Magic players? I mean, look.
It's a wheelbarrow.
Yeah, and
for somebody who does like landscaping and things like that, that's a wheelbarrow full of dirt.
Okay, yeah, it's a wheelbarrow full of dirt. But still, that's not all that big, relatively speaking, for a rock from space. So, you know, the explosion that you're going to have from that isn't going to be too terrible.
Okay.
You know, if you get something really, really big, that's when you got problems. So it's all a matter of size, right? So,
okay.
It probably did, well, here's the question. Did it really explode or did it merely break up? Now, there's a really good chance that you said everything kind of ramped up in brightness. It got really bright. Like, how fast did that happen?
Well, 1 second. Okay, imagine the moon about 4 times out of nowhere.
Okay,
like
now when you say out of nowhere, was it...
moon, you know how when you're in the woods on a full moon, like you can see in front of you.
Oh, yeah.
It's not quite day when this thing shows up. You know, it's not quite that bright, but it's like bright enough that, you know, I can see everything. That's not a problem. It's probably about half between a full moon and daylight.
Okay, now, did it go from like, normal darkness to this brightness like instantly, like just split second, or did it was it more like, turning up a dial?
It was pretty much split second, but like I said, I attribute that to the fact that it actually entered our atmosphere, according to NASA, directly above me.
Okay, well, the going from darkness to sudden brightness, that was actually probably it exploding, to be honest.
Oh, okay. Well, it had the tail and everything. I guess, cause you could see the tail. Like, the tail was there,
well,
you know.
I mean, to make it explode, you've got to heat it up.
Right.
So as you heat it up, it's going to get hot, and as it gets hot, shit's going to fall off.
Right.
I swore there. Oh, no.
Mark that down, folks.
What show are we on? Oh, man.
Cluze swore. I worked so hard in the last episode to get you to swear, and that just came out naturally.
I feel really bad about that. So stuff's gonna fall off, right? And so that's what your tail is that you're seeing.
Right.
But then it explodes, and well, now all the little bitty pieces gotta go places. I'm not surprised that you didn't necessarily hear anything. Did they say how high up it blew up?
No. They said the NASA camera lost track of it, like I said, over Katanning, and they didn't say how high it actually was at the point, because that's the funny thing. They said they lost track of it. I don't know if that means that it disintegrated, that it exploded. The local news, because that's trustworthy, they said it exploded.
Oh yes, the local news. They have been a wonderful source of scientific information since never.
Right. Well, it's funny. We actually have a NASA cam in town that I didn't know about, and this was captured on film. Like, I could send you the link after the show.
Oh yeah, absolutely.
If you want to look at it. It was cool. And I actually know exactly where that cam is. It's, right up by Geneva College's baseball field.
Cool.
It's at a college, so it makes perfectly good sense. Anyway, so it's been a year since we've talked about, our sciences and stuff, and
yeah,
a few really big things happened in the past year.
Oh, just a couple of little things that we've done since we last.
We landed on a comet, dude.
We did, and holy crap, that was amazing.
Yeah, I mean, initially when it first happened, like, I was amazed. I'm sitting there watching the TV, I got the Science Channel on, and I'm watching all the live feeds, and I'm just like, yes, fucking awesome. And then the thing bounced, and immediately I start snapping out. I'm like, how can you send something into outer space and not give it an anchor? And I even went on the pit imps and flipped out about this. I'm like, how can you not give it an anchor?
Well,
they did. I found out later.
Right. Yeah, okay.
They did. What happened? Do you know why the anchor malfunctioned, or did they not give it enough power to actually get into the rock? Or
well, let's talk for a minute about what they actually accomplished.
Okay, yeah, that's a good idea.
So first of all, we should mention that what we're talking about now is the Rosetta mission.
Yes.
Okay, and the Philae lander that was dropped by the Rosetta mission. And by the way, this is a fairly common thing to have happen, is that you've got more than one probe stuck together. Like Cassini. We sent Cassini out to Saturn, and Huygens was a probe attached to Cassini, and the Huygens probe was dropped down onto a moon. But okay, so Rosetta. So the idea was, and by the way, this was not us. Okay, this was the Europeans. This was ESA. This wasn't NASA. So although you'll hear a lot of people in the general public will say, "Oh, this NASA probe, blah blah blah." Nope, that was ESA. Okay.
Yeah, but Cluze, we're all one people.
Well, I wish we were. I really, truly do.
In the science community, it's more like that than it is in the political world.
It's closer to that. It's not quite that, but it's closer.
It's closer.
Okay. So the Rosetta probe. So the Europeans decided they wanted to study comets, and there are lots of reasons that you want to study comets. We can get into those in a few minutes. But so the idea was, we're going to send this probe off to this comet. They picked a comet that was on its way in, and they thought, okay, if we get the probe to the comet on the way in, we can study the comet as it goes around the sun. This will be great. We'll learn all kinds of wonderful things about this comet.
It looked like a rubber ducky.
Yeah, although we didn't really know it looked like a rubber ducky when we launched it. We knew that it looked like a thing. We weren't quite sure exactly what the shape would be. But yes, it does kind of look like a rubber ducky. So 10 years ago, they did the calculations, and they built this probe, and they launched it, and they sent it off on its merry way. So it's been cruising for like a decade to get to where it's got to go. Now,
yeah, but it spent its first 5 years spinning around Earth to build up speed.
Yeah, but still, okay, here's what I want you to do. I want you to get out a piece of paper.
Yes.
Calculate how to make this thing gain speed by going around the Earth for a while, and then fly out there to this thing. So, this comet that it went to, which has a really silly name that I won't even bother telling you, but it's got a really silly name. it's this teeny tiny little target that it's got to find in space. Okay. Space is huge. Absolutely, positively, mind-bogglingly huge.
Yeah.
And this thing's in motion. Okay, it's flying around the sun. So we're going to take our little flying probe and we're going to send it out to meet this other thing that's flying. Okay, this is not easy calculations here, but they did it and they sent this thing off. It's like, and I don't even have a good analogy for it. Imagine if you went outside right now with a golf club and a ball, and you hit the ball, and you hit the ball so hard that you sent it around the Earth several times. You actually went around the Earth for like 10 years, and then it came down and got a hole in one on a golf course on the other side of the globe.
Okay, I gotta call bullshit.
It's crazy to get a little tiny thing that you gotta hit, okay?
Yeah, but I still gotta call bullshit. Once you get something up to that speed, it becomes orbital speed and it'll just keep doing it.
Well, yeah, it will just continue in orbit. Look, it's not a great analogy, okay? What do you want from me?
I'm gonna call you out.
So they hit this, like, space hole in one to get this thing there. And they got it there, and they're now basically in orbit around it. They are orbiting it with the Rosetta probe. They dropped the Philae lander onto it. So, I mean, just getting there is a huge, amazing feat of science and engineering, and kudos to the whole team that worked on this.
Oh yeah, whichever mathematicians figured out that we gotta go around the Earth twice, and then we have to go around, Venus, and then we have to go back out around Earth again, and then we're going to bump a little bit of speed away from Mars, and bang, we're there.
Yeah, because it's not as easy as, just aim where it's going to be and just go there. No. It doesn't really work that way. Because, okay, I'm going to compare and contrast this with something that I hope we'll talk about a little bit later on. But they wanted to get to it and go in orbit around it, and that's the tricky bit.
Mm-hmm.
Okay, if you just want to fly by it, that's easy. Just aim where it's going to be and just head that way really, really fast. No problem. And that's basically what the New Horizons probe is doing, the one that's headed to Pluto, excuse me. New Horizons is just doing a flyby. It's not trying to go into orbit. It's just booking it out there to Pluto, and it's just going to zip right on by. It's going to get the one flyby, and that's it. But that's not what Rosetta's doing. Rosetta's in orbit, but Rosetta also dropped the little Philae lander. Uh-huh. Now, the Philae lander not only still functioned after 10 years of sitting in storage, but it landed, it actually hit its target, and was sending back data the whole time. Sure, it kind of bounced, and it didn't quite stick, but we didn't really know what the surface was going to be like. We didn't know what the topography was going to be like. We didn't know exactly what the gravity was going to be like. I mean, we kind of knew how much this thing weighed and how big it was, so we could figure out roughly what the surface, because, I mean, the surface gravity is tiny.
Yeah.
Right? It's not like you could go and stand there. If you go and stand there and you sneeze, you're now in orbit, okay? You don't really just stick to it. It doesn't work, which, by the way, is one of my huge one of many complaints about Armageddon. Because there's a scene in Armageddon where they're like drilling, and they've got these big long metal pieces that they're using for their drill bits, and one of them tosses it off the side of the ship that they're on, and it just falls, just like that, just like you're in normal Earth gravity, because, by the way, they filmed that on Earth. But still, the surface gravity is tiny. We don't know what the material is going to be like that it's trying to stick to. So getting it to anchor itself, okay, so that didn't work.
Yeah, when you think about all the things, and that was, maybe it was more of a disappointment to me that it was like, once I put together all of that stuff you just named, all the stuff that it took to hit it at just the right speed to where it begun to orbit around it. I mean, if it's going 2 miles an hour quicker, it's going to zoom past it. If it's going 10 miles an hour slower, it's going to miss it completely.
Yeah.
To hit it at just the right pace and everything else that had to go into it, it just disappointed me that it hit and bounced, and I'm like, now something has to go wrong on every one of these missions. I realize that, but it's just like you did so many just infinitesimally impossible things with this mission, and the anchor fails. But it's still there. I mean, it is still on the comet and still sending back data. And
Philae is technically in sleep mode and will likely never wake up.
Oh, okay. I know it did get a water sample though.
It did get some chemical samples that it sent back. I don't know the exact details of everything that it did. I am not an asteroid scientist. I am not a commentary scientist, but it's really freaking cool.
It is. It absolutely is really cool. I know the water, they said, they were a little disappointed because it wasn't the water composition that we have on Earth. It was a different type of water.
Yeah, so we'll get to that in just a second, but I just want to put into perspective just how low the gravity on this thing is.
Okay.
I went and looked up a couple of numbers real quick here. You know the concept of escape velocity, right? It's how fast you have to be going to get off of a body and into orbit. Okay.
Yes.
Escape velocity for Earth, I think, is something like 11.2 kilometers a second, somewhere around there. Okay, so you got to get your rocket going that fast.
Yeah, it's $10 billion. That's all you need, really.
Yeah, it's approximately $1 bajillion to get into orbit. The escape speed for the comet that Rosetta is around is estimated to be about 1 meter per second. Now, 1 meter per second is like 2.2 miles per hour. The average walking speed for an adult is 2.8 miles per hour. So that's right. Walking speed is escape velocity on this thing. So it's really, really low.
Yeah, it is.
So anyway, okay. What was it that we were going to get back to? Water. Yes.
That was the important part of landing on a comet. We all thought that's how we got our water, right?
Yeah. So let's talk about where the water on Earth comes from.
Okay.
Now, you could say, well, when the solar system formed, and we could go into a whole digression about the formation of the solar system if you really want to, but let's table that for now.
Yeah.
So when the solar system formed, Earth had some water just in the stuff it was made out of. Okay, we formed from the solar nebula, the big cloud of gas and debris that eventually became everything in the solar system. So there was probably some water there, but the problem is, as the Earth, compressed and contracted and became the big ball that it is now, it was really frickin' hot. Yeah. So hot that, based on the current models, there should not have been liquid water able to survive on Earth.
Not to mention the catastrophe that formed our moon would have just wiped out any water that was on the planet as well.
Exactly. The big collision that made our moon, which I don't know if we talked about that last time.
We did.
Too. Okay, good. So the question is, where did the water come from? And the leading theory up until, about a couple of months ago when Rosetta got there, the leading theory until then was, the Earth's oceans came primarily from stuff that hit us afterwards, from comets and asteroids that slammed into Earth after it was formed. Because there's lots of debris in the solar system after Earth was formed. We were bombarded by all kinds of rocks. If you don't believe me, look at the moon. The moon has all those craters because it gets bombarded with stuff. And I don't know if you know this, but the moon, totally in orbit around the Earth. So if it's getting hit, we were probably getting hit. So the leading theory was it came from comets. Okay, comets, we know that they're kind of dirty snowballs. They're made of rock and ice. Ice, water, ice, fantastic. That's probably what they're made out of. There you go. Yeah, there's a little problem with that. So let's talk about types of water, shall we?
Sure.
So what's important when you look at water is that, normal water, we're just going to go get a scoop full of water out of the ocean. And you're going to find that normal water is hydrogen and oxygen. You got 2 hydrogens, 1 oxygen, H2O. Our good friend looks like Mickey Mouse. Okay, so the problem is not all hydrogen is created equal. Some hydrogen, you might think, Cluze, that's crazy. All hydrogen is hydrogen. What are you talking about? Well, hydrogen, in its simplest form, is 1 proton and 1 electron. That's it. That's your normal hydrogen.
That's why it's number 1 on our periodic table.
Exactly. Most of the universe is hydrogen, by the way, quite frankly. So, some hydrogen is actually deuterium. And deuterium is 1 proton, 1 neutron, and 1 electron. Okay, so it's also known as heavy hydrogen, or therefore if you make water out of it, and heavy water is 1 hydrogen, 1 deuterium, 1 oxygen. Okay, so there's an extra neutron there. That's why we call it heavy water. There's 1 extra neutron. It literally weighs more than normal water. The thing is, there's not a lot of deuterium in the universe. We think that all of the deuterium ever was made right after the Big Bang. Okay, there was a period of time right after the Big Bang when the universe, and man, we're getting real deep into the formation of the universe here. But right after the Big Bang, the universe was hot and dense. Being hot and dense, we eventually formed subatomic particles like protons and electrons. And being hot and dense enough, you could slam protons into other protons, and you could slam protons into electrons. And by the way, if you slam a proton into an electron, you can make a neutron, which is kind of cool. And if you wanted to, you could slam a proton and a neutron together and get them to bind. You can get them close enough that the strong nuclear force takes over and they stick together. Well, the problem is that only worked for about 20 minutes or so after the Big Bang, and then after that we cooled down enough that just a stray proton and a neutron weren't going fast enough to actually come together and to overcome the forces required to actually stick together. So you could only make deuterium during this tiny window at the very beginning of the universe. And there's no other good mechanism for creating deuterium. Now, sure, you could try and contrive a way to create deuterium, but it's actually a lot easier to break deuterium apart, because photons with enough energy, if they strike it, can actually get it to pop apart. So we're actually destroying deuterium much more easily than we're making deuterium. So all the deuterium ever, we think, was created at the very beginning of the universe. So what you can do is you can look at the ratio of deuterium to hydrogen inside of, say, the water in the ocean, or the ice in a comet, or the water that's trapped in an asteroid. You can look at these ratios different places and say, okay, is this similar to what I have here? If so, then these are probably related in some way. So what you do is you go and you look at the Earth's oceans, and you say, okay, how much deuterium is in the Earth's oceans? And it's something like 0.01% of the hydrogen in Earth's oceans is deuterium. So it's a very, very small fraction. If you then go and look at comets, all comets that we've studied, without exception, have had a much higher deuterium abundance than Earth's oceans. So if the water in Earth's oceans came from comets, it should have a very similar deuterium abundance to what we see in comets, and it doesn't.
Okay.
And in fact, this comet that Rosetta's orbiting, it's like got 3 times the deuterium abundance that Earth's oceans do.
Now, see, this is where, the home scientist here, looked at this study, and I kind of said, we're heating this thing up when it enters our atmosphere.
Sure.
Could that have broken apart the deuterium? And then when the water reformed, because, it goes ahead and it evaporates and what have you, when it reformed into, actual water, is it possible that the deuterium just was lessened by just the sheer heating of it? Because like you said, photons, boom, hits it, and all photon is a light beam, basically.
Well, yeah, but it takes a very high energy photon to do it. You need gamma radiation to make that happen. It's not like shining a flashlight on it is going to work. But I see where you're getting at.
We are close enough to the sun, though, where, we get pelted. The aurora borealis. I mean.
Well, we do get some gamma radiation from the sun. A lot of that is blocked by the Earth's atmosphere, thankfully.
Right. But
so otherwise we'd all be dead.
True. But these comets are getting so close. You know what I mean? Like, before it's in our atmosphere, it's out in that garbage.
Sure, but I mean, the comets that we're studying now are out in that garbage, right?
Fair.
So if that's not enough to do it, I doubt that careening through the Earth's atmosphere is going to be enough to destroy enough deuterium to make up the difference. I'm sure it would lessen it over time. But still, if we look at other objects in the solar system to try and look for other sources for where the water could have come from, because I'm not saying none of it came from comets, okay? We're looking at a deuterium abundance, and we're comparing it to the deuterium abundance of something else. And so all we're asking, what we need is the average of the things that hit us to come out to what we have now, right?
Right.
So, if we look at, say, the asteroids in the asteroid belt, they have a much closer deuterium abundance to what we have on Earth. So we think it was material from closer in the solar system that actually created it, not the stuff from comets. Now we should probably talk briefly about 2 different sources of comets.
Kind of a recap. We went over the asteroid belt and the Oort cloud last time, but
okay, yeah. Most of the comets we see come from the Kuiper belt, which is out where Pluto's at. Okay, so out beyond Neptune's orbit. Some of them will come in from the Oort cloud, which is much further out than that. But basically, stuff from the Kuiper belt and the Oort cloud and beyond, that stuff is the stuff of comets, and those have, the ones that we've studied at least, have too high a deuterium abundance to have been a major source of water on Earth. So we're not exactly back to the drawing board, but we probably got more of our water from asteroids than from comets, even though asteroids have much less water than comets do.
C'est la vie.
So that's the important water thing from
The Rosetta mission.
Rosetta mission, yeah.
That was its big mission, a sort of, aside from actually landing on it.
Yeah.
that was the data that they needed to collect for the mission. So 10 years to come up with that.
Well, I mean,
That's science, though.
they're still studying other things, though. I mean, they're still getting lots of great information about the exact composition of the comet and how, we once had this belief that comets were, kind of imagine taking a mixing bowl and take a handful of dirt and a big handful of snow and mix it up in the mixing bowl and then kind of shape it into a ball. And we thought, there's your comet. Okay, it's got dirt and snow and ice and all kinds of stuff just kind of mixed up kind of homogeneously throughout the whole thing. But it looks like, at least with this comet, the inside is much more ice and the outside is much more dirt, if that makes sense.
It actually does make more sense. I mean, I look at the comets now as, your average person. I went outside, I made a snowball, and over time, dust just collected on the snowball.
Yeah, actually, people in the north actually have a much better intuitive sense of what a comet looks like. Because we're used to snow that hits the ground and stays for a while. And snow that stays for a while looks awful.
Oh, it's terrible.
Because it covers with dirt and dust and debris and all kinds of terrible stuff. And so the outside looks dark and gray and dirty. But if you dig underneath that, you get down to the pure snow.
Yes.
So that's, at least this comet is much more like that. Now, one of the big problems is chances are if you've seen a comet, you've seen a comet. So they're probably all a little bit different, but we're getting a lot better idea of what your typical comet is like.
Yes. Okay, so we know the next cool mission, at least as far as I'm concerned, is the Dawn mission.
Okay.
It's right now able to take pictures, very close pictures of Ceres. And
right.
Ceres is the planet that isn't a planet. It once was a planet. It was Pluto before Pluto.
Exactly. It's totally hipster Pluto.
Yeah. So, but they're actually going to get to study Ceres now a lot closer than what they ever have. And I myself find that to be really cool because, it's just a really big asteroid, basically. And that's the next big mission that we're going to get fruitful data on quickly. I know that, there is the one that's going out towards Pluto and beyond.
Yeah, New Horizons is next up right after that.
Yes, like directly after that. I mean, Dawn is really close. Like within the next couple months, data should really begin to start flying back. Pictures are coming back where, the thing is around. It just hasn't cleared out its space.
Yeah.
But that's the next cool thing to look forward to. But I have a little, thing here I wanted to ask you about, and I don't know, I might stump you on this one because I'm going to ask you about HAT P11b.
HAT P11b. Okay, I don't know that I know HAT P11b.
Okay, HAT P11b was a exoplanet discovered, I believe, about 4 to 5 months ago. And this exoplanet appears to have, the planet itself is about 3 times the size of Earth, and it has a bunch of water on it.
Ooh, beautiful.
Yes. If you don't really have a bunch of, okay. But no, that was something that I looked up. I remember reading about it when I was sitting down to go, okay, I need to talk to Cluze about, these things that went over the last year. I was wondering if you had picked up anything on that, but.
Yeah, that one I haven't picked up a lot on. I mean, the science of exoplanets, planets outside of our own solar system, it is probably the sexiest science that's going on right now, just because, it's fairly easy to capture the public's imagination when you go, okay, imagine Earth, but bigger and around a different star. Isn't that awesome? And people go, yeah, that's awesome.
That's cool.
So the number of exoplanets that we found is kind of staggering.
Yeah, we're well up over 1,000.
I was going to say, I suspect that HAT P11b was probably a Kepler planet. So Kepler is the satellite that's detecting exoplanets, and it's pretty darned good at it, quite frankly. So we've got like thousands of known exoplanets at this point. I mean, we went for the entirety of human history having no exoplanets known to having like 1 or 2, and then suddenly it was 10, then 20, then Kepler launched, and it's like, well, that's 1,000. Here's another 1,000 for you. Enjoy. So yeah, I mean, there are lots of new planets being discovered constantly.
Yeah,
Now,
that's really cool, but like you said, it is kind of just the new chic thing to do because we don't know enough about our own solar system realistically to care too much about that stuff.
There is so much to still be discovered within our own, heck, for that matter, there's so much to still be discovered within our own planet. I mean, there are huge swaths of the oceans that we don't know anything about what's going on down there. We find new species of insects all the time on our own. We literally live here. I mean, it would like be being in your apartment and you're like, I've never gone into that room over there, but instead I'm gonna go see what's going on in Japan.
Yeah.
So, there's lots of stuff to still be discovered, but I don't really know HAT P11b. It's probably, I'm gonna guess it's the most recent best candidate for, habitable planets outside of our solar system.
Pretty much. It's the largest exoplanet they've found with large amounts of water in a Goldilocks zone too. This is what's important about it, But then again, with the size of it and everything, like the Goldilocks zone is different because it's so much bigger and yada, 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 and so on and so forth. But I don't know. That's something you can look up, I guess. I do have another quick subject that I need to ask you about because this blew my mind.
Sure.
I just recently learned that scientists believe that we have a dwarf dark matter universe that just decides to orbit around the Milky Way. First off, what the hell is a dwarf dark matter universe?
Okay, well, I doubt that it's truly a dwarf dark matter universe. It might be a dwarf dark matter galaxy.
Galaxy, yeah, that's the word.
Sure. Okay, so let's talk about galaxies, then we'll talk about dark matter, then we'll talk about dark matter galaxies, okay? So, galaxies are, of course, collections of stars and gas and planets around those stars. Maybe we'll chuck in some black holes there, because there's probably a black hole in the center. And they're the big swirly things that you see in the sky, right? So the Milky Way galaxy is the one that we live in. The Milky Way galaxy is the most dominant galaxy in our local neighborhood, but it's not the only galaxy in our local neighborhood. In fact, for any listeners in the southern hemisphere, you're intimately familiar with a couple of other galaxies, and that is the Small Magellanic Cloud and the Large Magellanic Cloud. And these are two satellite galaxies that orbit our galaxy. They're much smaller than the Milky Way, but they're considered dwarf galaxies. They're small galaxies that orbit ours. Now, the SMC and the LMC, the reason they're called the Magellanic Clouds, Magellan, the guy who circumnavigated the globe? Well, mostly. I think he died before the trip ended, but still, Magellan, when he was circumnavigating the globe, when the sailors were on their ships at night, they kept seeing these clouds that were up in the sky that never moved. They were always there. That's how they got their name. Okay, it was the Small Magellanic Cloud and the Large Magellanic. Anyway, those are galaxies. We have a bunch of different galaxies that orbit our own. We've had some that have merged with our own. If you actually do studies of the gas in our galaxy rather than just the stars, but the stray gas, you can actually see some tails where other galaxies have collided with ours. Now, they're small galaxies that have collided with ours, but still, they collided nonetheless. Although, okay, look, when we talk about galaxies and collisions, it's not as cool as it sounds. Okay, when I say collision, you imagine something smashing into something else. But honestly, if you take two galaxies and throw them at each other, chances are none of the stars will hit one another because most of the galaxy is empty space. They'll just pass through one another, but they'll interact gravitationally. Anyway, now we have to talk about dark matter briefly, and I think we probably talked about dark matter last time, but just to recap. So dark matter's just a catch-all phrase for matter that interacts gravitationally but does not glow in the visible spectrum, in anything we can detect with our instrumentation that we have. Okay, so that
it bends light. That's as much as we know that that's the only reason we know it's there.
It doesn't necessarily mean that it's evil, although it might be. I'm not passing judgment. It doesn't necessarily mean that it's evil, just that it's not bright. And
it's not Hitler.
Yeah, and I don't mean that it's stupid. I just mean that it's not glowing, okay? So, the idea is that there's something orbiting our galaxy that is massive enough to be a dwarf galaxy, but dark enough that we can't actually see it. We can just see how it interacts gravitationally. And so that's most likely what the dark matter dwarf galaxy is. Now, the better question that I have is, why is it not glowing if it's that massive? So that's curious.
That's what's tripping me out. Like, how do we not detect this thing that's, so close to us that it's in orbit with us, but it just there's nothing there. It's spooky.
Well, let's define close for a minute, shall we? I mean,
okay.
our galaxy from side to side, because our galaxy's kind of squashed. Think of it kind of like a plate. It's flat, or at least flat-ish. If you go the long way, not the skinny way, but the long way, it's about 100,000 light years across. So if there's something that's orbiting our galaxy, it's probably more than 50,000 light years from us, probably a lot more than that. So, I mean, to say that it's close, well, there's close and then there's cosmically close. Yes, cosmically. Holy crap, this thing is close. But, in most people's experience, no, this is really far away.
No, it's not next door. It's clearly not that, but I mean, in the cosmic sense, like you said, because we pick up lights, especially now with the satellites we have in space, we pick up lights from so far into the past, it's unreal, and it's like, this thing is technically right there. How can we get nothing off of something that's right there?
Yeah, I'll be honest. I don't really know much about the dwarf dark matter galaxy. Now, I do know that like 2 days ago, there was some new measurements that indicate that a star passed like right by our solar system, like just whizzed right by it.
Just a rogue star.
Yeah, just a rogue star. It was a fairly small star. It's not a great star, quite frankly. And in fact, it may have a really crappy brown dwarf companion that's with it, but still, it just zipped right by us. Came really, really close to our own solar system.
Cosmically close, folks. Cosmically close.
Right. Again, it's not like you went outside and you said, "Holy crap," and you ducked and the star went by. No. It's not quite like that. Although, you know the Onion, right?
The Onion? Yeah, Shrek.
So, no, The Onion, the newspaper, which is
yes.
So The Onion over the years has had some really great articles. My personal favorite headline ever was "Disgruntled Office Ninja Silently Kills 4," which I thought was great. Since the people in the article were questioning why they even employed an office ninja anyway, but still. There was another one where a new solar system was discovered that was like 20 feet off the Earth. It was just right there and no one ever noticed because we were always looking up and not down. And so there it was. And, they were going to put a ladder up and climb to one of the other planets. But anyway, it's a great article from the archives from way back in the day on The Onion.
Oh, fake news.
Yes, fake news. Sometimes slightly better than real news.
Except when people believe it.
Yeah, oh God, yes.
I mean, there is that danger because like I know people, the old crazy ladies who, bought the Weekly World News every week when it came out and would tell you everything in there was true. And it's like, okay.
Well, I happen to know the fact that Bat Boy is living with Elvis in Grand Rapids, Michigan. I mean, everyone knows this.
Yeah, and Tupac.
Yeah.
Elvis, Tupac, and Bat Boy. They're forming a band.
That's right. They're going to have a hit album. We absolutely swear.
Yeah, it's going to happen.
What's really great is when foreign news organizations pick up on articles in The Onion as if they're real.
Yes.
That's fun.
It is. So, Cluze, not to, put you on the spot because I love doing that to people. But I solicited some questions. These were, I got a lot of responses. So we'll try to rip through as many of these as we can. I understand that a couple of these are probably going to take a few seconds to answer. And some of them you just might not be able to answer. And if for some reason you cannot answer it, just be honest and say, I have no clue.
Oh, yeah, I'm actually always happy to simply tell you I have absolutely no idea. But yeah, okay.
Okay, so here's the first question I got. And this one is actually pretty good. There's a little bit of thought here. If the universe started at one point/place,
sure.
And what we think we can only imagine to expand in a radical type, directly expanding out, why is Andromeda destined to collide with our own galaxy?
Okay, so the question itself is flawed.
I know. I told him I could answer, but I'll ask you.
All right. So, yes, the question itself is flawed in that it's not that the universe started in one place, okay, because that implies that there is a place that is outside of the universe or a coordinate system outside of the universe. And we can go, oh, look, the universe started there and then it expanded and now all this stuff is over here. No, it's not really like that. The universe started. Okay, so we're just going to stop the sentence right there. Universe started, but all of the places in the universe, which includes where we are and where Andromeda is, were also starting there. Okay? So you have to jettison the idea of the Big Bang and the origins of the universe. You have to stop thinking of that as an explosion in space. Take any kind of Michael Bay-esque vision that you have in your head of that and just throw it away, because it's not how it worked. It was an explosion of space. Space itself exploded. So,
Everybody
imagine
got that.
Yeah, everybody got that? Okay, we're all on the same page. So, space itself explodes, okay? And the early universe, imagine that you're there in the early universe, it is very, very dense and very, very hot. So hot and dense. The universe at this point is tiny from one side of the universe to the other. Let's say you were a photon bouncing around in the early universe. It's very, very tiny. You can just go all over the universe all the time. It's just bouncing back and forth in the universe.
By the way,
Yeah?
I hate to cut you off.
Sure.
This is the real use for the word singularities. Just
Yes.
point that out. It has nothing to do with computers and them becoming intelligent. This is the real use of the word.
Now, the universe then suddenly gets bigger, and I don't have time to go into why that happened. This is a thing called inflation theory, where the universe goes from being teeny tiny and very dense and very small to being incredibly huge almost instantly. Okay, so we're just going to make the universe really big, but it's still really dense and hot. It's not as dense and hot, but it's still really dense and hot. So dense and hot that we don't really have stuff, we have energy. Now, once we make it much bigger, we can start to make stuff out of energy. Because remember, energy is stuff, okay? E equals mc squared and all that jazz. We can take energy and make matter out of it. And that's what happens in the early universe to make our hydrogen and our deuterium and later our helium. Okay, we're going to make all that junk. Don't worry about that. We'll make it. But now we make that junk, okay? But it's still just junk. It's still like free hydrogen and free electrons. We haven't actually made, it's free protons and free electrons. And actually, technically a proton is just ionized hydrogen, which is a weird way to think about it, but trust me, it's true. So we still haven't made stuff out of it. We need to take the proton and give it an electron. Now we have hydrogen. We need to take some hydrogens, build them into helium. Let's take some heliums, build them into heavier stuff. Eventually we'll build them so that we've got oxygen and we've got hydrogen. We'll stick them together and now we can make water. Great. Everybody's happy. But first we have to make hydrogen. And now that we're making hydrogen, we're making clouds of hydrogen. And now that we're making clouds of hydrogen, we can start to make stars. So we'll start with a universe that is a big diffuse soup of energy. Then we'll make it into a big diffuse soup of stuff and energy. Then we'll take that stuff and it'll clump together, okay? Much like, here's actually a cool thing. Anybody out there ever eaten miso soup? If not, you should. I encourage you to eat miso soup. Miso soup actually does this really cool simulation of the formation of galaxies. And I noticed this one day when I was eating at a really great Japanese restaurant. And so I took my miso soup and I stirred it up so that all of the stuff was kind of diffused all over inside of the soup. And then I set it aside and I ate my salad, which was a delicious salad. And then I turned back to my miso soup and I'd left it long enough that all of the little particles in the miso soup had started to clump together and they made these big like strands and webs of stuff inside there. And that's what happens when you try and form galaxies in the universe. They form these strands in these webs, okay?
Uh-huh.
So, you've got these galaxies forming that are clumping together in places. And we clump together some stuff and we make the Milky Way, and we clump together some stuff and we make Andromeda, okay? But the thing is, all of those two clumps actually want to make a bigger clump that is Andromeda and the Milky Way stuffed together. So we're falling towards Andromeda just because we hadn't gotten around to clumping with him yet, if that makes sense.
Yeah, it's all about gravity.
It is all about gravity, not the film, which I haven't seen, actually.
Oh, please don't. As a scientist, it'll drive you bonkers.
Yeah, well, lots of stuff in the cinema does. So, hey, that was a great rapid-fire question.
I know it was. That one comes from Dustin Sims, and I want to thank him for that.
Thank you, Dustin.
He does have other ones here. Maybe we'll get back to another one of his questions, but I thought that one was good. We have a fun question here, and I don't know if you know the individual he's talking about, but he says, if Sid Meister was an alien, what would he look like?
I have no idea.
Okay. I think we covered this during the last show, but Larry Slade wants to know, Why we kicked out Pluto. And there's a quick answer to
Okay.
that, I'm sure.
Yeah, why we kicked out Pluto. We didn't. Pluto's not a planet. That's okay.
It never was.
Yeah, it never should have been is actually the correct answer.
Yes.
But yeah, go listen to the last episode I was on, but here's what it boils down to. I'll try and give like the 1 minute answer. Either Pluto's a planet, and so is Ceres and a whole bunch of other things, and we've got like 11 or 12 planets easily. Or Pluto's not a planet, and we just have 8. Okay, Pluto's not as special as you want Pluto to be. It was a planet for historical reasons.
Yeah. And the things to make you a planet is you have to be round, 1, and 2, you have to have cleared out all the junk in your
orbit.
your orbit around the sun, and Pluto hasn't done B.
Yes, it has not done it. If there's a checklist, it has not checked off B.
Yep.
And so there you go.
That's why. Okay, but thanks, Larry. Jason Roscom asks us, do you believe that there is intelligent human-like life out there? And if so, will humans ever meet them before we go extinct?
This is a great question. Absolutely great question. Thank you for it. So let's break it down. Do I believe that there is intelligent human-like life? Not necessarily. Do I believe that there is intelligent life? Yes. Do I believe it's necessarily human-like? Not necessarily. I mean, human beings are an incredible marvel of years of evolution to get us to where we are now, to make us look like we do, to act like we do, to think like we do, physically to be like we are. The life that's out there, it's probably carbon-based just because carbon is so good at sticking to things. So it's probably carbon-based, but would it necessarily be bipedal with 2 hands and, the kind of axial symmetry that we have? I don't know, maybe. Honestly, I really think that a quadruped with arms, centaurs, I think would actually be it would make a lot more sense, right?
It'd be colder, too.
Nearly as much.
It'd be so much colder. Centaurs!
Yeah, it would be absolutely cool. Now, no, don't take the takeaway message is not Cluze thinks there's centaurs. No, that is not the takeaway message. The takeaway message is, yes, I think there's intelligent life. No, it is not necessarily human-like. Now, will we meet it in our lifetime? Well, what do we mean by meet? Will we physically interact with it in the lifetime of human beings as a species? I am very skeptical of that. Will we communicate with it? Yes,
maybe.
But it will be terrible communication because the distances we're talking about are stupendously big, right? And I think this is something that we talked about at least briefly last time. The nearest star to our own is 4 light years away. 4 light years. If I want to send a message to them, if I just want to make a text that says, "Hi, how you doing?" and I hit send, it takes 4 years for that signal to get to them. Then they've got to read it, then figure out what the hell it says, because they don't actually speak English, because why would they? They've got to translate that, figure out what it means, and go, oh, okay, I see what this guy said. He said, "Hi, how you doing?" "I'm fine, how are you?" And they send it back, and now it takes another 4 years to get back to us.
And we're all dead.
And we're probably all dead. So, I mean, that's an 8-year round trip for a message, and that's the nearest star to our own.
Yeah.
So, if you want to go any further than that, just establishing communication, just giving them enough information about our language to actually understand what we're saying is going to take a great amount of time. So yes, I think we will quote unquote contact another civilization at some point before human beings go extinct, but I don't think we'll physically get there because that was moving at light speed, right? Which we can't move at light speed.
No, we'll fall apart and become nothing.
Yeah, so how are we going to get to them in that time? So I actually don't think we'll actually physically, unless, and I'm not saying it's not, but unless faster than light travel is possible, which we have no current operating theory for how that would work. I'm not saying it's impossible.
Wait, we do? Yeah, I mean, look, there's no practical applications to it yet, but I mean, the folding of space theory.
Well, okay, but I mean, string theory is technically a thing too, but that doesn't mean that it works.
Okay. I'm just saying, there's theories at the moment. It's just, they're not working theories.
Exactly.
They're beyond what we grasp now, but I like to believe that in 2,000 years, civilization as we know it will advance to a point where they might make that possible.
I am cautiously optimistic that faster travel is possible. I don't believe it's probable, but I'm not saying it's impossible. So I don't think we'll physically interact with them, but we will find them for a certain value of find.
Cool. Okay, thank you, Jason. Next one, it comes from David Schmuck, and this one's going to be probably I don't know, but
okay.
What are each of your thoughts, so he's asking me as well, on the universe having no starting point? recent quantum physics has a new theory, and he posts a link here. I got to read over it, and the Big Bang Theory is just so tidy to me.
Yeah, although I abhor the show, the Big Bang Theory is actually a really good one. It explains a lot of things. So, the universe having no beginning is an interesting quantum mechanical model, but I'm not sure that it's anything more than that, honestly. If for no other reason, I need it to explain deuterium abundance, right? Okay. Earlier we talked about how to make deuterium, and we needed Big Bang nucleosynthesis to do it. I'm gonna need whatever theory you try and replace the Big Bang with to adequately explain things like deuterium abundance. If it can, then sure, we'll talk about it. But I don't know enough about the universe with no starting point theory to really speak about it.
Yeah, I mean, the big thing is like, it's like, okay, it starts I will read the first thing here, and this is, one of the problems that I have is when they take things like, it proves general relativity, they say, but then they add these things that they like to call, quantum, where's the word? Ah, damn it. Never mind. It's like their own little, we're going to make this work. And it's like, I don't like when you add numbers in there just to make it work, because
you have to prove where saying this is a fudge factor, but this might be a fudge factor.
That's what they're saying. So,
okay, sure.
But I can send you that link if you have any interest in reading it.
Yeah, I'm not going to reject the theory out of hand, okay? I think any time because new theories come up all the time, okay? The way science works is we have a theory for how the universe operates. Along comes a better theory. We get rid of the old one, we replace it with a new one, and that's just fine. Some people find that unsettling. Some people can't take that, and that bothers them. And okay, then don't be a scientist. But as a scientist, we cannot simply reject that which is different from what we know now. However, in order for a new theory to supplant the old one, it has to be better than the old one. Not just newer, not just more interesting, but actually better. So I don't know enough about this one to really comment on it.
Okay, fair enough. We got another one here from Zikai. I'm not even going to try your last name, right? But it's, how much infrastructure is needed to make space mining a reality? Can they update the Hubble telescope to get even better imaging than what they have now? I'm not sure what they do at this point. And how many universes does Cluze prescribe to infinite? 11, 42?
Okay, so let's take these one at a time. How much infrastructure is needed to actually make space mining possible? So first thing we're going to need is a actual space vehicle to get people off of the Earth and to another object. And right now, we don't have that. Okay, we had the Apollo program and we sent human beings to the moon, and that was awesome. We don't really do that anymore. I mean, even if you look at the probes we've sent out, they're tiny and they're not coming back. Okay, because getting out there, oh man, we're good at that. We can launch crap way out in the solar system. We have a probe going to Pluto. This
and beyond.
Tiny little rock, and we're gonna go right by it. But it's not coming back, okay? You need to be able to launch something out and either have some mechanism for it to refuel itself or launch it with sufficient fuel to come back again. And that's tricky.
Right.
So if we're going to do it robotically, that's fine. We could probably pull that off. Probably within a decade, we could start to actually, and I'm spitballing here, okay? This is just an estimation. Within a decade, we could probably have probes to go and retrieve small quantities of material and bring them back. To actually retrieve large quantities of material, to actually use them for mining, for actual, I want to go get, let's say we were desperately in need of, gold, okay, and we find asteroids that have gold in them, okay, well, we're gonna have to fly out there, find the asteroid, mine the asteroid, get the gold, bring it back, and we're probably not gonna bring back the rest of the crap, we'll just bring back what we want, so we'll have to have some automated method for separating out the stuff we need. That, we're probably several decades away from being able to do that. Now, if you want to send human beings to do it, 50 years and an adequate budget, I mean, don't get me wrong. This year is a cause to celebrate. The budget for NASA this year is higher than what NASA asked for.
Whoa.
I know. I'm just floored by this concept. So, we first have to fund it before we even talk about the infrastructure needed, the actual physical devices we would need to do it. So, tens of years at the least is what I'll say to that one. Okay, second one. Can we upgrade the Hubble Space Telescope to look at, better things? No. Now, I know that sounds harsh to just slam the door on that one, but the Hubble Space Telescope was constructed such that it would live in low Earth orbit so that we could send the space shuttle up to it to fix it, and then the space shuttle could come back down. We don't have one of those anymore. The space shuttle is done. We shut that project down. They're gone. Okay. We don't have a vehicle that can go to the Hubble Space Telescope to upgrade it. Because the Hubble Space Telescope, it is built for upgrading. It is built such that an astronaut can go on a spacewalk with a wrench and a screwdriver, and they can take the panels off and stick crap inside, pull out the old camera, put in the new camera. We did all kinds of great stuff to upgrade that thing. But we can't get to it anymore.
Right.
So
it's no with the caveat of not at this moment.
Yeah, we would actually be better off, and this is something I wish they had done, just go and get the blueprints for the Hubble Space Telescope, fix the math problem that screwed up the mirror, and build a new one and launch it. That would actually be easier than servicing the one that's there.
The only problem with that, and I do believe the number, the current number to leave our atmosphere is $10 billion. Because, we have to have something new every time that goes up, doesn't it?
Yeah.
So it's extremely expensive to do that. So, yeah, I don't see us doing it anytime soon myself. Now, our last question that he asked was, how many universes do you prescribe to as infinite?
Well, okay, that actually has built into it the tacit belief that I believe in infinite universes. And I am unconvinced. Now, here's the thing. There may be infinite universes, but we can only actually interact with the one. So even if there are an infinite number of them, so?
Okay. I actually read it, I shorthanded it. But he actually does right here. How many universes does Cluze prescribe to? Infinite, 11, 42?
Okay.
Yeah.
One that matters.
And a whole bunch that we can't talk about.
Possibly an infinite number that we can't talk about.
Yeah. Okay. Let's see. Okay, this is a question from the same guy who asked us about the crazy, quantum mechanics theory. This one's a little more answerable.
Okay.
Also, Mars travel is happening within our lifetime.
Well, hopefully, yes.
What are your thoughts on them sending people on a one-way trip? I know my thoughts on it. If those people want to go, fuck it, let them go.
That is pretty much my answer too. I have absolutely no problem with sending people who know they're not coming back. Okay, I am fine with that, okay? At some point, we have to leave this planet, period, full stop, okay? We cannot stay here forever, or we will all die. And that was covered in our last show.
Yes.
So, how do you get off the planet, okay? You kind of have to look at, in some ways, I kind of hearken it back to the early days of sea exploration, okay? When sailors left on a long voyage on a sailing ship away from the lands they knew into lands beyond that were uncharted, they had absolutely no idea if they were coming back.
Right.
Now, it was probably pretty good. They could turn around and come back.
Well, it depends, because there was the flat earth theory, and a lot of them believe that if you got close enough, you could turn around.
The flat earth, I'm gonna call this the flat earth myth for a minute. The idea that the earth was flat was not held on to nearly as long as popular culture wants you to believe. But, true, okay, early sailors wouldn't have known.
Right.
But still, once you do know that, it's round, but I'm probably not. I mean, you look at disease, you look at storms, you look at the technology of the day, they probably weren't coming back, okay? There's a reason that you said goodbye to your family when you left the dock, not I'll see you later. It was, I may not be coming back.
Yeah, you go out there and get the rickets and never come back.
That's right. So, if we're gonna send people to other planets, there's nothing intrinsically wrong with sending them on a one-way journey, okay? As long as they fully understand what they're doing when they do it, I have no problem with that. I don't think there's any kind of a moral problem that's going on there. Is it the best use of our resources? Well, It's hard to get things off the planet, and unless they're going to build an engine to come back, I don't really want to launch the engine to come back with them, because that's a lot of weight to give them the fuel to return. So there's nothing really intrinsically wrong with a one-way trip, honestly.
Yeah, I mean, realistically, somebody's got to do it first. And if they want to do it, by all means.
I'll be honest, if I were a younger man, I might have volunteered.
I would not.
That's perfectly fair.
It is what it is. I mean, yeah, it's real easy to sit there and, romanticize the ideas, I'm going to be on Mars, but it's a lot easier to say, I'm going to stay home and play MTGO.
Yeah, well, maybe not the MTGO. It depends. Version 4? I don't know. But, yeah,
Lots of updates this week, I hear.
This is true. I hear it's getting better, but I can't actually verify that because I don't actually play MTGO.
Okay, I have two more really quick ones.
All right.
And then we will wrap this up. Okay, so.
Sure.
This one comes from Anthony Watroba, and this is a good question, because you study the outer atmosphere, outer space. So, how much space junk is orbiting the Earth, and does it interfere with your studies?
An ungodly amount, and not much, honestly. So, how much junk? I don't have a good number for you, but I can tell you that is a stupid amount of junk orbiting the Earth. At this point, it is only a matter of time. As I understand it, in the film Gravity, which again I have not seen, a satellite gets destroyed and it sends debris that hits other satellites. Yeah, that's not that far-fetched. Okay, that could actually happen. If you, I'm not saying that you could walk from one satellite to another, but it's pretty bad up there. Now most of this junk is very, very small, and so it doesn't get in the way most of the time. But I will say that I have seen satellites in images we have taken, right? I mean, as we're taking images from the ground up into space, yep, occasionally a satellite will just fly right through the frame, and that totally happens. It's very rare, and it usually doesn't go in front of the object we're looking at. It just goes through the edge of the frame, but every now and then it does. I'm pretty sure, let's see now, I've been studying gamma ray bursts for going on 8 years now, 9 years now, and there have only been a handful where the satellite got in the way. So it's not that bad, but we really need to get to the point where if we're going to launch something, we need to get something else out of the way, if that makes sense. It's kind of like boy, I hesitate to use this analogy because it's going to sound mean and callous, but there have been suggestions that if anyone tries to climb Mount Everest, you should require them to bring some garbage back when they go up there, because so much garbage has been left on the mountain that it's starting to get to be a problem. We kind of need a same kind of idea, okay? We need a way to get junk out.
Yes. Send those people who are going to Mars with some bags.
Now, the more modern satellites tend to deorbit themselves when they're getting towards the end of their lifetime. Now that doesn't always work out. See also Skylab. Oops, our bad. I don't know if you know Skylab, but we actually dropped it on Australia.
Yeah.
Yeah, which by the way, we have still not paid the fine for littering, but Australia did sue us for littering.
As well they should.
Yes, absolutely. Anyway, I'm sorry. I took a long time on that one.
No, it's fine. I mean, hey, it's your time you're giving me, so if you want to take as long as you want to answer these, I'm not going to argue, but, I know that you have to get back to your work, so.
Yes, sadly, I wish I didn't.
Yeah, this is going to be the last one, and this is directed at both of us. Okay. So I will answer first, and then you can correct the dumb one. Look, I'm an intelligent guy, but between the two of us, I mean, your job's so much cooler than mine. I'm just going to call a spade a spade. I'm the dumb one. Okay.
Oh, don't sell yourself short, but okay, go ahead.
Okay, so since we are bouncing around time in the cons block, so this one's a little funner already. I'd like to hear you guys' thoughts on theories and possibilities of time travel. I'm going to give mine first. So, here's my theory on time travel. You can go forward in time. Light does it all the time. Because time is, what's the best word? It's relative. So, moving forward in time, I believe in constantly. Going back in time, no. Cluze, you can correct me if I'm wrong.
Sure. No. I actually overall agree with you. Okay. But I'm gonna get real empirical on this one. Okay. If time travel were possible, where is everybody? Because either time travel is not possible, or this is a really boring time in history that no one wants to see, or they're really good at hiding.
And I'm not going to go with the third one.
Yeah, so I don't think
beings blab. That's just what we do.
Yeah, we're not real good at keeping to ourselves. See also Facebook and Twitter. So, I do know that, God, who was it? Some famous scientist held a party.
Some famous scientist? You don't know his name?
Yeah, was that actually Hawking who did that?
Yes.
Okay. I wanted to say Hawking, but if I was wrong, I was going to feel really bad about it. But Hawking
was in fact Stephen Hawking.
He threw a party for time travelers and then sent out the invitation afterwards, and no one showed.
Nope.
So, take from that what you will.
He sat in his room, in his office by himself.
Yeah.
I felt his handler with him. But yeah, all night.
So, if time travel were a possibility, I would think that we would have done it by now, or we would have seen evidence of it by now. There is a possibility that, maybe they're just really good at hiding. Or, there's also a theory, and I can't really comment on the math on this one, there is a theory that once time travel is invented, you can travel back to the point where time travel was invented, but no further. And so that's, I guess, a possibility. The thing is, Angelo is right. You are a time traveler right now. Absolutely. If you don't believe me, look at your watch, look away, look back at your watch. You are traveling through time. You're just going in one direction. Sorry about that. Maybe we'll be able to go back someday, but today is not that day. I don't think time travel is actually possible, just because, again, empirically.
You know what? I lied to you, Cluze.
Yeah.
I got one here that I didn't see all the likes next to it.
All right, hit me.
And this is definitely going to be the ender. This is nothing but a fun question.
Sure.
If there is other intelligent life out there, do they also hate Jace?
Okay. You ready for this?
If they're intelligent, they love them.
I'm gonna drop a bombshell on you, and I'm gonna say no. And here's why. They may not yet know about Jace, and therefore can't yet hate him.
Well, I'm just going to say that if that's the case, they're not intelligent, because intelligent people want to win the game, and Jace lets you win games.
Hey, look, there are a lot of things that let you win games. That doesn't mean that they're healthy and should be allowed.
True. A 45 would win you a game quickly.
But again, I do want to stress that I think that Jace should be unbanned in Modern.
God. I just love hearing that out of you. So, Cluze, we're going to wrap it up, until, I guess, next year, probably, if we do this again, or who knows, if people enjoy this and scream about it enough, maybe me and Cluze can get together more often and do these.
Yeah, share it with your friends, push it on social media. If you enjoyed it, let us know. Maybe it'll happen some more.
Yeah, I love these talks, but realistically, if it's just me and Cluze getting on here so I can pick his brain every month or 2 months or 3 months or whatever, I'm going to drive the man bonkers. So, Cluze, real quick, if you want to give everybody your contact information, let them know.
Sure, absolutely. First of all, let me say it has been an absolute pleasure to be on here. I have enjoyed every single minute of this.
Cool.
And I'm not just saying that because this is so much more fun than the work that I'm supposed to be doing right now, but if folks want to hear more out of me, I can, of course, be found just about every week on the Monday Night Magic podcast on the MTG Cast Network. Every now and then I'm traveling or away and miss out, but still, we have fun over there. You can also find me most weeks on the Card Advantage podcast, also found on the MTG Cast Network or on our own website that is cardadvantagecast.com. Not to be confused with cardadvantage.com. They're a card shop. We're not affiliated with them. It's just a coincidence in names. Sorry about that. If you want to reach me directly, your absolute best bet is on Twitter. I am at LaCluyze, which is spelled just like in the show notes, but since I know that all of you are not going to go to the show notes, it's LACLUYZ as in zebra, E as in echo. So LaCluyze, that's how that's pronounced. So There you go.
And I promise you, it will be in the show notes. I have gotten a lot better at posting links to people's Facebook pages and Twitters. So
yeah, although again, I don't think anyone reads the show notes. I'm just saying.
Yeah, I really don't either. Yeah, it seems like a lot of work for no reason. I actually did an experiment one time, and I hate to digress off, but I just posted random things. Like I started the way I normally do, and then I just start put in there like dinosaur, stop sign. Does anybody read this? Balloons, rainbows make me happy, and nobody for like 2 weeks got back to me about it. So
for a while, I was putting jokes in the show notes to Card Advantage, and I think I started telling a joke, and I was telling it one line at a time, and then I eventually just stopped, and no one ever noticed.
That's exactly it. But if you wanted to get a hold of me, you get a hold of me at Gonksuo on Twitter. That's GANKSUOU. Same thing on MTGO. You can also it'll probably be in the show notes, or it'll be over on the Pit Imps page. We have a GoFundMe to help improve our sound quality and things like that. Please help us out. We're going to do a lot of cool things once you do. Also, you can hit me at pitimppodcast@gmail.com. Please get a hold of Cluze, get a hold of me. Let us know what you think about this episode. And if this is the first Cluze episode, go back and listen to season 1. Trust me, if you enjoyed this one, you're going to enjoy that one as well. It's a little more basic, but it's not as centered on certain things, but it's great. And Cluze, thank you for coming on here. I love these chats.
Oh, I do too. It's been an absolute pleasure.
But until the next time we can do this, I'm going to have to talk to you guys later.